Yeah, welcome. My name is Jason Oliver. I'm the chair of the Architecture and Interior Design Department. So what I did, and this will seem a little organic because it really is by intention or by design in some ways, because what we're doing here is very organic as far as 3D printing, and then obviously this larger makerspace endeavor that we have going on here in this particular room. And I'm hoping this is actually more of a discussion so that we can almost learn more from each other rather than me standing up here for 2 hours just kind of saying, okay, here's a bunch of 3D printers and this is what they can do. Because I think to some degree that's academic. You kind of know to some degree what they can do. We've started using them with our students in a variety of different ways. We've got projects coming up that are going to be pushing the boundaries a little bit. And so I'm almost curious to hear what you guys are doing or would like to do, or if you have ideas about what you'd like to do, and maybe we can brainstorm on ways to achieve it, how to kind of bring it together. So the first thing is just an overview of what we've done here at the college. Our first 3D printing was basically off campus. We have a kind of strategic partnership with some of the industry in the area. Over at ATE, which is one of the defense contractors, we had a satellite campus called the CAT, which is the Center for Competitive Applied Technologies, basically. And we teach our students in their facility certain programs, SolidWorks and a few other CNC programming, and those students more often than not go to work for that employer or for the employers kind of in the area that utilize those same skills. They had the first of the 3D printers. It's this giant behemoth one. Very rarely used it because they didn't have much need for it, but they had the technology, and occasionally some of the students, when they might show an interest, they'd fire it up and they could print out little widgets or something like that. So it really wasn't used as an instructional device necessarily to the level that we do now. On campus, in our MESA lab, which is our math, engineering, and science lab, basically, they started doing 3D printing for those students. And again, it was sort of on a voluntary basis. As students would show interest, they would come in and say, hey, I'm thinking of building a robot, and I need a 3D print part, can you guys help me out? And so they would be sort of collaborative, but it wasn't a structured curriculum of any kind. The third thing on here, which is the ARCID, which is my department, Architecture and Interior Design. So about 2 years ago, we got a series of 3D printers, one of which is over here, this Ultimaker, which I've got turned on. And we started to do, first it took us a little while to kind of learn how to use them, and then we started to deploy it to some of the students. And so some of our advanced students that had an interest in 3D printing projects started to play around with it, but it was very facilitated. So the instructors would basically be there doing the printing, for lack of a better term. It wasn't really the students, hitting print or dealing with any of the troubleshooting on the printers themselves. So it was very labor intensive for our department. And then finally on here is the makerspace. So about 18 months ago, our chancellor had the vision, after seeing what other schools were doing relative to makerspaces, is to establish one here. Sort of slowly and organically, we've been building up this facility. This used to be a staff lounge, this room and the room adjacent, and then so we sort of took that over, cobbled together a bunch of equipment, some of it being 3D printing. We've got a laser cutter, we've got various soldering and small hand tools, and even in the other room we've got a CNC, that's a router over there, Coleman?
Yes.
CNC router, and the idea is we'll start expanding tools as different needs arise. I mean, we even got a sewing machine from the theater department. I personally brought my architecture design students down here, and by the end of the semester we were pretty extensively using it, and I've got a couple projects I'll show you of how they were using it. It wasn't any formal curriculum in the sense that I was saying, okay, all of you, I'm going to teach you about the equipment. I showed them basically what it could do, but it was up to them to either learn a 3D modeling program and work with the makerspace staff to get stuff printed. So we've kind of gone from a very hands-on approach to here's the space, have at it. And that seems to be the direction that we're going to go. And from a academic standpoint, in the K through 12, I don't know from a high school, middle school, or elementary school, the logistics of it, how that approach can apply and what the benefits and the drawbacks are. The next thing on this agenda, I've listed 4 kind of foundational skills, and this is really kind of where we see the makerspace benefiting students. You know, we can obviously fairly easily integrate 3D printing into you know, a science curriculum or an engineering curriculum or something like that as a, you know, just kind of a tool or, you know, sort of a shiny toy. But I think we'd all agree that, or I hope we'd all agree, that these kind of foundation skills are really what we're trying to get at, or the opportunity that's out there with this technology is not just to teach them how to 3D print, but to teach them how to, in many ways, self-learn. A lot of this technology requires that they not just hit the print button, but that they learn how to operate a program and to, oh, I don't know how to get this information from this computer over to this computer because I've got to translate the file, so they have to do some research. You know, and they're obviously very comfortable going onto the web and looking up, you know, whatever Rihanna's latest CD is or something like that, and they can do the same thing for this type of technology. So I guess that's where I would like to even start the discussion on some of you that may already be doing some of this stuff. What lessons learned do you have on things like, you know, self-learning for a K through 12 student? You know, is it successful, not successful? Maybe not even relative to 3D printing, but just in other kind of projects that you've worked on, maybe working with kits or some kind of a lab thing. One of the other things, I'll show you an example. In fact, I met with one of our anthropology instructors yesterday. Part of what we're going to be doing in here is, in some ways, helping them with, you know, helping a lot of the departments with different things. So, oh, thank you. So she came in with this. This is a printed or a manufactured orangutan skeleton. Okay. And so what she said is, we can buy these off the shelf. That's pretty straightforward. But what we'd like the students to do is this, which are actuated skeletons. And I'll pass that around. And I thought, well, you know, that's an interesting project. We have competitions we do up through the makerspace here. Maybe that could be a competition where we have anthropology students, engineering students, maybe art students or something else. How can they print the bones and then manufacture some sort of a mechanism to, you know, actually make it active or work in some way? And so it takes what would be a fairly traditional or very compartmentalized anthropology lesson and actually integrate in, you know, several other disciplines. And so I know, like with my kids in their school, where a lot of the classes are coordinated. You know, what they're learning in English applies to what they're learning in history and so on and so forth. And so obviously that's a great synergy between disciplines of doing a project where you use the 3D printing technology for the science component, the math component, you know, so that they all kind of talk to each other in a way. So we started printing out, this was actually a soap dish. I don't know if I wanted to have this in my bathroom, but yeah.
Say maybe for Halloween.
Halloween would be kind of cool. So, and then we took the anthropology instructor, she gave us, she showed us where there's a database of models of different skulls and bones and whatnot. So this is a public source jawbone from some Paleolithic person, I guess. You know, so we just printed that out this morning. It took about, Daniel, what, 2 hours or?
Hour and a half, 2 hours.
Hour and a half. Okay. We did have a few hiccups though, and that's anybody that's familiar with 3D printing will understand or appreciate this. You know, we started printing it, and it got to about, you know, maybe a third of the way up or something, and then the printer stopped. Oh, great. And so we basically lost that time. You know, and I think that's one of the biggest, for me, one of the biggest limitations of 3D printing is the time involved in the predictability or lack of predictability. You know, especially when you have students, you know, who aren't going to wait around for hours for something to print. You know, in fact, when we do our show and tells here on campus, and I bring out the 3D printers and we have it, you know, doing its thing and it's dancing around, and people are like, wow, it's amazing, you have the 3D printer, you know, like, how long does it take? And I say, like, 8 hours. And in today's kids' minds, that's like an eternity. I mean, they're used to just hit and go and getting whatever they want instantaneously. So, you know, it does give you pause sometimes of how it can be applied in the classroom. At Pasadena City College, or excuse me, at Portland City College, and actually I'll kind of jump over to my PowerPoint a little bit here. And just kind of run through the tour of their facility. It has some similarities to what we're trying to do here, but it also has some things that, some lessons learned, things we wouldn't do. One of the cool things, though, is about branding their space and just having students aware that these things are on campus. Even if they're not in that class, that okay, that class is the only ones that get to use this technology. It will at least encourage them to start using it. We still get students in here all the time that say, I know there's a makerspace, but I'm not sure if I can go into it. Can I touch this stuff? And so we actually, tour people around here and say, yeah, come on in. This is like a library. Come in and start using it. Hang out and start talking to the people that hang out here. And so we now have a kind of a community that's building up. And so just having some sort of identification and awareness is a big part of building that culture up. Most of the makerspaces have some kind of sign-ins. We're still feeling our way through the liability part of all this. We have woodworking tools and whatnot. Now, obviously, schools have traditionally had shops, so it's not new ground for you. When we were up in Portland, they were literally casting a molten computer in like a lab with like 40 other people that were all doing bandsaws and all that stuff, and students working on something like, wow, okay, it's different up in Oregon. Not as many lawyers, I guess. But one from a funding standpoint, obviously a liability standpoint, and having some kind of record-keeping system. We actually have our students, I think, do a card swipe of their ID card so we can kind of know who's coming and going. We're still funding this right now from a variety of sources. And so that's also something that's going to be different for everybody is where do you get the money from? Is it from a specific department fund? Is it a grant? Or is it just a general fund expense that the school picks up? The other thing that was kind of cool, and this is something where we're going to start going into, is actually, this was an advertisement for several small workshops. So you could come on, in this case it would look like a 1-month class and learn about laser cutting. So you might even have little boot camp classes, come for an afternoon, come for a Saturday or something like that, learn about this particular technology so that you can then just jump on and start using it and not need to be facilitated by the staff here because they're always running around doing 60 other things. And that's another way to obviously get awareness is just having these workshops. So at Portland, they had taken over what was their auto technology area, and they converted it into a kind of an open lab space like this, and then a sort of more of an academic classroom or a computer lab, each one of these terminals having its own dedicated 3D printer. So they have probably 20 3D printers in here. So in that setting, they were able to get every single student to work on their stuff and print it without sitting around waiting for somebody else. But obviously there's a fairly large expense, to being able to do that. Storage, of models, that's something that we really haven't broached here yet. Right now, all of our students bring their stuff with them and take it home with them. And I would imagine in your classes it's very much the same. You don't really have, dedicated spaces for each student. And so some kind of storage where at least, when a 3D print is done, you put it there, you put a little tag with their name, and then, they have 24 hours to pick it up or something like that, because you've got other prints coming right behind it. This one here is at Portland. This other one is up at the Makerspace at Pasadena City College, and it's just about that promotion part that we all have to do. Not just promoting it to students, but you've got parents coming in. You want to get them excited about, the technology and what their children are up to. The administration has to be, buy into the whole concept, and obviously the public as well. So there's always sort of a promotional aspect. I mean, just the fact that we're all kind of here is sort of a promotional aspect as well, raising awareness about it. So you kind of build that into your workflow that as students do, like a capstone project, you find a way to reap some more benefits out of that. So this is a picture of the individual workstations up at Portland. So they were fairly small because it was just for the makerspace environment. There were other printers elsewhere in the facility, but this is where they would actually hold the class, and each student would be at a terminal in their print station. And then when no one's using the class for an academic class, students can just come in and pick a station to sit at and work on a project. And they also kept track of they had like a little folder basically at every single print station. Students had to, fill in some information, how long the print was going to take, how much filament, the actual plastic that it would use. In their case, most of this was being funded by the department. What we do here, and correct me if I'm wrong, our students have to purchase their own material and bring it in. And so if you're trying to keep track of the cost of this stuff, you need to have some kind of a log, whether it's just a hand, written something like this, or it's an actual digital thing. So in this case, when we were up there, they printed out these little Pikachu Pokemon things. Our makerspace has gotten past the action figurine phase. There's actually like the first 6 months is the wow, I can print Superman or whatever. And now we're actually doing more project-based stuff that's more directly tied to their curriculum, to the stuff they're doing in classes. But we've got our fair share of, fairies and lightsabers and all that kind of stuff, which is fun.
I didn't bring that.
It gives people, one of the things it does is what brings the students in is they usually have something they want to print. A lot of people come in here and print stuff as gifts, like that little skeleton hand. It was like a gift for somebody. And then once they're in here, then they're like, wow, what else can I do in here? So this student who was doing a lightsaber, they actually printed it on their laser cutter as a prototype, and played around with it, modified it, and then they printed the final version on the 3D printer. One of the things they do at Portland, though, and this is actually kind of interesting because it takes this whole dynamic off campus. For several years now, they've been creating prosthetic hands for local kids. And so they have a group of kids that are missing maybe a hand or something like that. They come in, they fit them, and then they sit down with the student or this kid and they kind of design, well, what kind of a hand do you want? And depending on some of the samples they have here, they'll print it any color they want. And so a lot of these kids are like, I want a pink hand, or I want some kind of design on it or something like that. So it really gets them excited. So it's a pretty amazing thing and quite simple at the same time. And so that's kind of the fourth item on here as a foundation skill. Talk a little bit about collaboration between disciplines, but just sort of students, so often I get students, well, where can I find an internship? And I say, create your own. It allows students the ability to start doing that. Even if it's just like creating something small that they can sell to their friends, it gets them, it can kind of create a money-making opportunity for them doing something that they would find, enjoyable. I have on here something that we learned in my department, which is exercising common sense, kind of picking the right tool for the job. And we found out fairly quickly, particularly because of the time constraints in 3D printing, that it wasn't always the right tool for the job. It can do a lot of great things, but if something takes 12 hours, 24 hours to print out, maybe, when you have a 2-day deadline, it's really not the ideal thing. So that's why complementing it with some of these other technologies like the laser cutter, we found, at least for my discipline, was a godsend, because then students could stop for a minute and say, okay, for these pieces I can print those very quickly. For these things, I can use the laser cutter. So like, for instance, this model here, I'll show you where geometrically it's pretty cool, but he originally considered 3D printing it, and it was just like, gosh, the fact that you could invest all that time and have it not turn out would seem like a really bad situation. So he realized that it would be much easier just to use wood and the laser cutter to actually create like the trees and the people. And so this is basswood, cardboard, chipboard, and so just sometimes taking a step back and thinking about what limitations this technology has. And it kind of hit home because I have kids, and I didn't realize it, and I'm like, they're using 3D printing right now, like my daughter in elementary school. So fast forward 8 years, when she's in college, her expectations are going to be much more advanced, than just, doing little Pokemons or something like that. So I'm thinking, well, how do we anticipate, what their needs are going to be? And I think for me, I came to peace with it by having these kind of foundational skills, that really I'm not teaching you how to 3D print. You probably are going to know better than I am how to 3D print, but I can teach you how to think, how to challenge, how to visualize, that particularly in my profession, that's really important, is physical visualization of spaces that don't exist yet. So we use virtual reality goggles and things like that. you know, kids right now, a lot of them literally have their heads buried on a digital device, you know, and so they're not always kind of spatially aware in the way that kids might have been 20, 30 years ago. So those are skills that I think they're going to need. Another idea in here is developing your academic ecosystem. It sounds very academic just to say that, but you know, it's really, again, what we're trying to do organically here is we're reaching out to the different departments. Like I met with Anthropology yesterday, I met with somebody from our biotech department today. How can we bring them in here, bring their students in here, and then once they're in here, then they get contaminated with the idea that there really are no kind of rules here. And it's a little hard for students to kind of grasp that because so often they're compartmentalized into, you know, like he was describing this morning, I'm a biology student. You know, why would I want to deal with some kind of motors or something like that? Well, I don't know, but you never know what, maybe it's some, you know, some sort of device that has a total biology purpose for it, you know? And so getting to think outside of the traditional modes of how they ordinarily have to think academically. We do competitions here. We've had one so far. We're in the brainstorming process for another one. And so I'm going to actually skip ahead a little bit to talk about that. We had, in October, we had the EcoZombie Robot Challenge. And it was one of those things where we wanted to have an event and we didn't really quite know what to even do. We wanted to get students excited about something. We didn't have any money to spend, you know, it was one of those deals. But what we did have were all these like Lego robot kits that were left over from a couple semesters ago. And we're like, well, what can we do with them? You know, well, we could have the kids build robots. Okay, that's kind of neat. But how do we get cross-collaboration between different disciplines? So what we ended up doing is kind of theming it around Halloween. It was right before Halloween. And we made it a zombie challenge. So not only did the students have to build these Lego robots, program them, and that they could do a variety of different things, but they also had to create an identity for it and costume the robot, you know, so it actually brought sort of an artistic side to it as well. We had the event on a Thursday so that, you know, it was time on campus when there was a lot of people here. Everything was free. We provided all the supplies. And we ended up having 40 students compete in 9 different teams, and then probably about maybe, you know, 70 or so people showed up for the actual event. It was on an obstacle course, and the idea was that these little robots would have to transport recyclable materials to a recycling center, which was in the middle of the obstacle course, and obviously put little barriers up and stuff like that. It was done in 2 different heats. We had about, I think, a 40-minute heat. We had a break. Students made little modifications. They had like a 15-minute window. So this particular team, their robot had a Christmas tree with a witch's hat on top of it. This team over here, we'll see their robot in a second. It was pretty amazing. And it was also kind of a battle bot. So while this event was going on, and we actually held it out here in the cafeteria, it was just a raucous atmosphere, absolute blast. And so the robots were attacking each other, stealing their recyclable cans from each other, and trying to deposit them in this little circle right here. And so they get a point for everything they did. And so it was timed, and so it was obviously, you know, added to the excitement level. The one robot, this one here, this was the Michael Jackson robot, even with the white glove and everything. And we didn't realize it at the time when we broke for halftime. You know, they're like, well, you know, this thing can dance. I'm like, what do you mean can dance? And they're like, yeah, we want to do the halftime show. And literally, they had a whole stage set they did where Michael Jackson robot came out of this like box and he danced around, and it was really kind of funny. It's sort of an unexpected surprise. But we had like a princess robot. This was a referee. You know, so everything was a zombie theme. So again, having some sort of event like this where you can hold it on campus somewhere where everybody sees it, gets excited about it, it's fairly cheap to do, and yet it brings together students that ordinarily wouldn't, you know, come in contact with each other. And we had some prizes, I think some gift cards we give out. So some of the winning teams. And then they got to keep their robots at the end with the idea that they could either improve them for next year, probably hold this annually, or just, you know, play with it at home. This is my little corner of the world up in the architecture department where we actually have 3 3D printers, these 2 Ultimakers, one of which is here. And then this other one, which is the Luzobot. Price-wise, we spent about $3 on this Ultimaker, and I swear I would never spend that much on the 3D printer again for all the headaches that it gives us. When it works, but when it doesn't, it doesn't. And so, but it does good work. Like Chris had printed out this wind turbine and then hooked up a voltmeter to it. So, you know, that's not turned on here, but if you spin it and then you put the little things in there, it actually generates a charge. You know, so it can print, you know, fairly complex three-dimensional stuff. So that would be something that could be a project for students where they could print something and obviously add some electronic component to it. You know, and you can get a lot of this stuff as kids. I mean, you just go down to Radio Shack and get the voltmeter, right?
Yeah, voltmeter was like $5.
Yeah, so fairly inexpensive. Are there bearings in the?
Yeah, there's bearings up in the top, and it's basically just what you see up at the top is a fake generator, just for an example. But there's a shaft that runs down, and in the very bottom, in the base, is an electric motor that instead of running from power is actually generating power. Now it generates like very little voltage, of course, because of its size, but it was basically a principle that it can, you know, generate.
It demonstrates,
right.
Yeah. You scale it up.
Right, you scale it up and it'll generate decent power.
So this piece of equipment, these two are combination printer scanners, and so what they do is you can put a thing inside of there. Like what we've done with our scanners is I've taken some of our architectural models. You know, we have our students do some of these little abstract, you know, chipboard things, you know, when they start learning about space and solids and fluids and stuff like that. So we've scanned those, and then once it's in the computer and digital, then they can either take it into a program like Maya or Rhino or one of these CAD softwares, and then we can either 3D print it out. This is a different model, but it, you know, kind of showed the quality of the model that comes out on the other end. You know, so the idea is we're trying to get our students to not just think everything has to be done in the computer, or it all has to be done physically. You can kind of bounce between the two worlds, you know, hopefully as seamlessly as possible. That's kind of where we're hoping to push the technology so that they have that ability. So this particular model, and there's several manufacturers that make these combinations, you know, where it can do both scanning and printing in one package. My understanding in talking to Portland is that, you know, they're pretty pricey, and again, reliability is kind of the issue because a lot of this stuff is, you know, is being in some ways pushed to market a little bit before it's fully vetted. So there's a lot of on-the-ground troubleshooting. This particular model, you know, you're kind of limited by the size of the bed, that flat plate, you know, where it actually scans or prints the model to. So the envelope that it can deal with is fairly small. You know, so for instance, to print out this windmill had to be done in several parts. You know, there's what, 8 or 12 parts to make that up?
About 12, yeah.
You know, and then it has to be assembled. So that's a consideration. And obviously, the bigger the envelope you get, the more expensive the printer is. We're doing, I think, on our big printer over here, 12 inches cubed is kind of the biggest thing that we can do. And that would take a while for something that big to print out, depending on how complex it is. Kind of another neat thing, when we were up there, I was sort of the guinea pig. They had a handheld 3D scanner, and they scanned me in it, and took it into a very simple program called PaperCab, which is on this handout. So it's a free 3D modeling program, very simple to use. So that's why it's good for makerspace, for just cleaning up models or just doing simple things. And then they printed me out. So there's, I guess, a couple of me out in the world now. And then they gave me the file, and I was kind of curious, you know, how would this compare if I printed it on our printer? So on your right here is the one they printed out. They printed this out fairly quickly. It only took about 45 minutes. And then I took it on our printer and printed it out at a little higher resolution, and it took about 2 hours to do. But again, the idea being that you can take physical objects, scan them so they become virtual, whatever it is. You know, again, it could be a science project, it could be an art project, it could be just about anything, you know, sculpture or something like that. And then once it's in the computer, you can manipulate, you have the ability to do a lot of things you can't do in the physical world, and then hopefully it can print out and become something. these are the big printers. This is the one on the left's at Portland. The one on the right was at Pasadena City College. We actually have the same printer in our CAP, in our off-site location. What this printer does a little bit differently than the printers that you see around you. These are all kind of like inkjet printers, and they are the fused deposition. They basically deposit layer upon layer upon layer of a plastic material, and they just build up the object. And for most things, that's pretty good. Like for that bust of my head, it works out pretty well. But where it has trouble, obviously, is in voids and things that are open. You know, and it didn't occur to us, or didn't occur to me until I started printing things. You know, like we printed out the Eiffel Tower and this kind of stuff, that these things cannot print on air. You know, and so just because you can do it in the computer doesn't mean it can actually physically print out. So, like this Eiffel Tower is actually pretty rough, you know, when you look at the detail, because most of it is actually where the printer is trying to print on nothing, you know, or it's actually kind of slowly, incrementally working its way in. This building, which we actually do in one of our Revit classes, one of our 3D modeling classes, this is a building up at CalArts. And so in order to get the windows, the window frames and all that, we had to use this printer. And what that printer does is it actually has a solid material, and then it has another material which is going to be dissolved away, and that material then is the voids, basically. The problem with this is it has to be dipped in like a saline bath or something like that. So it's a little iffy, but I know, Coleman, you were saying the new ones now are water?
Yeah, Ultimaker, they came out with their #3 printer, and you can actually have support material that just dissolves in regular water.
So you don't have the
It's pretty cool.
toxicity.
So you don't have to deal with anything else. It just dissolves in water, and it's safe to just pour down the drain.
So that's something that's a good thing. And by having that type of printer, it opens up spatially a lot of objects that ordinarily would be tough to print with these the traditional you know, ones where it deposits layer by layer, not tied to gravity quite so much. One of the resources on here that I had for K through 12 ideas, it mentions a elementary school class that was studying about birds, and the kids used one of the free programs to build a very crude nest for the bird, you know. So they started thinking about, you know, how do you create a nest? You know, what shape is it? You know, is it made of individual components? And then they 3D printed those nests out. This is a fairly simple activity, but at least gets them thinking about, you know, building a nest in a way. So depending on whatever subjects you teach, you know, there could be a fairly simple project or something you do some other way that could be adapted or converted into a 3D printing activity. That's what I would do. You know, with my students, I take, you know, for 20 years, we've had them build abstract models like this. Okay, can I sit down with you for an hour, teach you how to create really simple forms, cylinders and squares and cubes and all that in the computer, and then show you how to print it, and then you can do that same activity, but now using this technology rather than just an X-Acto blade and some board. So that's kind of my spiel. Now, if you want, obviously, we can talk about specific things. If you want to take a look at our equipment, we've got a whole bunch of examples of models here.